This lesson should be relatively short. We've talked about absolute value equations, so we're going to look at absolute value inequalities. And the key part of this is, just like absolute value equations, we're going to have to make two separate equations to solve them, but we're going to have to remember that the second one we have to, in addition to making the number positive to negative, we also have to change the inequality symbol. So let me show you a couple examples of what I mean by that. So let's say we have the problem the absolute value of x is less than 3. Well, to make two equations, we're going to make one looks just like the original, except there's no absolute value bars. But the second one is going to be, we're going to change this to a negative 3, and we're going to flip the inequality. And what you get graphically when you do this is either the graphs are going to go towards each other or away from each other, but they will never, under any circumstances, go the same direction. What I mean by that is you're never going to see a graph that looks something like this. If you ever, in the course of solving absolute value inequalities, if you ever have a graph and the arrows are pointing in the same direction, something's wrong. They're either going to point towards each other. This is right, can't be. They're either going to point towards each other or they're going to point away from each other. Another example of that is 1/2 x plus 5 is greater than 17. So everything is in the absolute value bars on one side of the inequality by itself. So that being said, we can make two separate equations. And the only difference between the two equations is that the inequality is going to be flipped, and the other number on the outside is going to go from positive to negative. Then you're going to solve like you do any other inequality. So I got two things here. I'm going to graph them on the same number line, and I've got greater than 24, open circle, and less than negative 24. So, see, the arrows are pointing away from each other, or they're pointing towards each other, but never going in the same direction. And then applying some of our rules that we had from absolute value equations, you can see how to solve some of these other guys. Like, for example, here, we're not ready to make two equations yet. First, we have to get the absolute value stuff all by itself. We do that by adding 3 to both sides, and then we are ready. And 2x plus 3 is less than negative 12. So 2x is greater than 9, x is greater than 9 halves, or the same as 4 1/2. And over here, we subtract 3, we get 15, and x is less than negative 15 halves. So greater than 9 halves and less than negative 15 halves. Less than always to the left, more than always to the right. I think you probably got the hang of it by now, but I want to give you another example of something you might see. This one's kind of tricky. First of all, we've got to subtract 8 from both sides, which makes it look like we have a problem, but in actuality we don't, because this negative out here, we have to divide both sides by negative 1. We divide by a negative, we have to flip that inequality symbol, as we've done in the past. Now we're ready to make our two equations. Whoops. Sorry about that. So we have 1 minus x is less than or equal to 1, and 1 minus x is greater than or equal to negative 1. So negative x is less than 0, or x is greater than or equal to 0. When we divide both sides by negative 1, we have to flip the inequality. Negative x is greater than or equal to negative 2, or x is less than or equal to positive 2. So a little bit trickier, but doable. And they graph just like they would look. Less than or equal to 2, greater than or equal to 0. And finally, one other case, just to keep you on your toes. X plus 3. Well, we know that no matter what is inside these absolute value bars, either positive or negative, when it comes out of absolute value, it's going to be positive. So is it ever the case that it can be less than negative 2? And no, that is the big null set. That's it.